I'm Liliana. Hello, everyone. I work as a data scientist at the Data Science for Social Good Lab, which is part of the Carnegie Mellon University and part of the Machine Learning Department and Heinz College of Public Policy. We work under the leadership of Professor Rajiv Ghani. And mainly the work that we do is try to help organizations and agencies in how to implement correctly ML, AI, and DS projects in public space. So today I would like to talk to you about one phase on a DS, ML, AI, whatever you want to call it, project that it's often very, I would like to say, not as frequently used, underestimated, and also most of the time even forgotten. But I think that it's a very important part of the whole thing that you need to actually analyze before deploying any solution in the real world. I will start with presenting to you, like going through the typical life cycle of a data science, machine learning, AI project. That have like different stages so that we are all in the same page of where exactly post-modeling happens and why it happens. So we start with the problem identification and the scoping. And within that, what we are doing is just trying to define the goals in terms of efficiency, effectiveness, equity. Also trying to identify what are going to be the actions that we're going to actually do. What is the data available that we have? What is the analysis that we need to do to actually inform those actions to achieve the goals that we have defined? Identifying also the different stakeholders that need to be part of this project, and also the ethical considerations that we need to be aware of for this particular project. Once we have this scoping, which could happen in months, and it's also an iteration, we go and move forward to the data acquisition, in which mainly we have like two different things, like the legal stuff, in which we are trying to assure the data user agreements so that we can actually use the data that we're going to be using for the analysis. Also, all the legal issues on de-identifying the data and privacy and all of that legal things that needs to be resolved first. But also, we are also having the other part, which is the data analysis that we are going to be starting to do to check if we have enough or relevant or sufficient information to actually do the project. Once we do the data acquisition, then we move into the fun part, quote unquote, which will be the modeling, in which actually we start to do different experimentations on definitions of the cohorts, definitions of the labels, which features are we going to be creating, so that we're going to be using those as predictors, which models, which algorithms, which hyperparameters are going to be using for different models. So we're going to end up having like thousands of different models and experiments, because also they are going to be in different time chunks, so that we can actually check if we are generalizing well through time. So in that aspect, we're actually going through all of the modeling, and we're going to be doing performance evaluation so that we can check how well each model is doing, basically or typically in metrics that we know of as accuracy, precision, and recall. Most of the time, at least for public policy and social impact projects, the two metrics that are more important and are precision and recall, because we are measuring efficiency and effectiveness. So once we do this performance evaluation for each of the models that we actually built, we're going to check also the bias measurement and see if we are fair in how we are predicting the outcomes. And if not, maybe we can do some mitigation. Then we're moving forward to the model selection, in which, based on the performance evaluation that we have for all the models that we have built, we're going to select a subset of no more than 5, maybe 7 different models that has like the best performance based, again, on the efficiency and effectiveness, which are the goals that we define for our project. and also the bias measurement. So we're having a subset of the best models based, again, on performance. But that's one part of the model selection. Another part, which is a second iteration, it's where post-modeling actually happens. Once we have this subset of models, we will actually need to select just one that actually is the best to move forward and try to deploy in production. So with that model selection, we're going to talk about what we need to do to actually select that best model. But once we have selected that, we will move forward to the model validation, in which we will require to have a field trial so that we can validate the effectiveness of the solution. If the validation is successful, then we're going to deploy this model so that we can inform the actions that we have identified in the scoping part of the project. And we're going to be monitoring the solution so that we know that we don't have data drifts. If they are, we need to do something. And also if the model hasn't had any degradation, and if those, then retrain the model. So that's like typically the project life cycle that we have for the SML AI project. Again, what we're going to talk about today, post-modeling, happens on the second iteration of the model selection. So what is this post-modeling phase, and what are we trying to do in here? In this particular phase of the model selection, what we're trying to achieve is trying to understand what are the characteristics of the entities that are being selected or highlighted as having the highest likelihood of experience or having the outcome that we are actually interested in predict. So we are doing a deeper analysis on this subset of models so that we can actually know and understand what's going on. Who is the people or individuals or entities that are selected at the top K of our list, and who are we leaving behind? This is, again, an important part of the analysis that most of the time is not actually even done, but I don't think that that is correct. The main difference that we're going to have between the first iteration of selecting this subset of models and this part of post-modeling in particular, in which we are selecting just one model, is that for the subset of models, we only use the performance and bias metrics so that we are sure that we are selecting the best ones that are generalizing well over time. While in the post-modeling part, we are actually trying to understand who are those entities, what are the characteristics that they have that we are highlighting as the top K or having this highest likelihood of experiencing or having the outcome that we are interested in. So it's a different type of analysis because on the first one, you're doing performance as the metric for selection and bias. On the other one, it's more understanding who is part of this selection. Before we move forward into which type of analysis we do when we are doing post-modeling analysis, I first need to talk about what I mean when I say lists and top K, because I already have said that, but maybe it's not a very common concept in the DS or ML or AI solutions. So every time that we generate a model, we have generated a list basically from the entities that are part of the cohort, and each entity will have a score. That score goes from 0 to 1, where most of the time the highest scores means that the model is in highest likelihood of presenting or having this outcome, whilst the lowest ones or the lower the score means that you're at lower likelihood of presenting or experiencing that outcome. When I say K, the top K means the capacity of the organization. So if, for example, the capacity of the organization to actually do the intervention. So if the organization only can outreach 20 people, that K will be 20. And then we're going to be focusing on the top 20 individuals that are at highest likelihood of having or experiencing the outcome. So that's what when I'm saying top K in the list, that's what I'm referring to, those scores sorted by the score with the top K, with the highest likelihood of experiencing that. With that in mind, what type of analysis can we actually do when we are talking about the post-modeling? We already said that what we are trying to achieve when we are doing post-modeling is trying to characterize, like, what's the type of entities or which characteristics the individuals that are in these top K lists have. So one of the analyses that we do is called crosstabs, in which we are trying to do within the same list for a cohort in one model. We would like to know what are the differences between the features that we use to predict, so that we know what happens with the people that are on the top of the list, in the top K, versus the rest of the list. Are there any differences? Where are those differences? But these are mainly based on the features, the value of the features we use within the model. You can also do it between different models in which you're going to be comparing different lists. So for example, if you're interested in knowing what are the values of the features we use for the top K on this model versus the values that we use on the top K of this other model, you can also do that. But mainly we use it within the same list in one model just to check what are the differences between the individuals that are selected as top K and the rest of it. We can also do overlaps in which we are doing an intersection of the entities that we have in different lists from different models. This basically is just telling you if the same entities are part of different models. And it's very interesting when it is not the case. So for example, if you have a very low intersection of overlaps or very low overlap, what it is telling you is that the individuals that are part of the top K on those solutions are very different, which is, I guess for me, also it's very interesting. You would like to know which type of individuals this one actually is highlighting versus the other ones. You can also do a characteristics of the lists that you are generating, and this is more like a descriptive analysis, knowing which demographics they have, for example, age, race, gender, also which entities are part of the top list and which ones are left behind. We already have talked about that a little bit. And you can do the comparisons between different models in different lists. You also should be interested in knowing the type of events that the entities are having in your top K, which is also associated to the events that you have within your label window of prediction and after your label window of prediction. That's also like very interesting to notice that maybe you are having errors on your top K, meaning false positives, but when you're actually analyzing what happens after the label window, maybe they are actually having the event that you are trying to predict, but it happens afterwards. So it's also very interesting to see maybe you have one model in which it's highlighting people in a very preventive way, like 12 months ahead it happens. We're going to see an example of that on one real use case. That's mainly what you would like to do. Like the events, try to see like which type of events are associated to the individuals that are on the top versus also the outcomes, right? You can also do error analysis in which you are trying to see which type of features are the ones that are more correlated to false positives and false negatives. For the false negatives, you would need to check the whole list of the output of the model, but for the false positives, only looking at the top K, which also will give you interesting information about different models. And also the last three, but you already have done this first iteration of performance bias and feature importances when you were doing the first iteration of the model selection, which is this subset of models based on the performance. But again, you can do it in the post-modeling analysis. So let's see how some of those type of analyses are done with a real world use case in which we are trying to reduce the impact of behavioral health events in two counties in the US, Douglas County and Johnson County, both are in Kansas. The goals for this particular project in terms of effectiveness, efficiency, and equity are associated to this use of the limited resources that they have. We're going to see that they have only like 100 they can only outreach to 100 individuals a month. So in the efficiency goal, we would like to use those 100 resources to people that actually are going to have these behavioral health events. The effectiveness will be associated to the outreach of the individuals highlighted by the solution. So how well this outreach is actually helping these people. The equity is how are we going to actually select the people that we don't have like more, that we are not actually amplifying the gap between different races, ages, or ages or sex, right? Because it could be the case. So for this particular project, the analytical formulation that actually matches the operational setup that we have deployed, because we already have deployed this one, goes for each month. We're going to see from all individuals that have interacted with a system that we call MyRC. We would like to identify from the last year, so that we have interactions from the last year on this MyRC system. We would like to identify 100 individuals that are at highest risk of presenting something that we call a very high acuity event, or behavioral health event, in the next 6 months. That's our label window, so that we can recommend proactive behavioral health outreach. In here, the K will be these 100 individuals, so we're going to be looking at the top 100 individuals that are highlighted by different models. And this very high acuity event corresponds to events, behavioral health events, as deaths by suicide and overdose, suicidal attempts, suicidal gestures, diagnosis, ambulance runs, and also overdose, ambulance runs, severe substance use, and homicidal intentions or actions. So as you can see, they are very acute behavioral health events. And we would like to predict with 6 months ahead which people are going to have these behavioral health events, so that we can outreach them first and try to help them. So in particular for this project, at this particular stage, for the post-modeling phase, we already have selected a model that was doing very well. But eventually we found out that they also had this other solution that we call the scorecard, which is just a client risk scorecard. It's a set of rules that they use. When we don't have this model, they were actually using it to prioritize all the referrals that they get, so that they can actually prioritize and see who should visit first, right? So the question that we have right now is, does the current model of the machine learning solution could actually be enough instead of using the scorecard, or do we need to use both? Or which type of people are we missing if we get rid of the scorecard? So that's mainly the questions that we would like to answer. So based on the information that we have for the post-modeling analysis, we found out that for the demographics, if we're only looking at the top K, these 100 individuals highlighted by our model and highlighted by the scorecard, if we are only looking at the true positives within that list, we're going to see that the current model, which is going to be the machine learning model, and the other one is going to be called scorecard. For the machine learning model, the average age is 38, whilst for the scorecard will be 31, which is almost the same, but there's a difference in there. We have the same distribution in sex or gender. 49% are female, the rest are male, the same for the scorecard. For demographic also, we have a little bit more in other race, highlighted by the current model. And for the scorecard, we have more Black race identified for the scorecard. If we look at the events from the past, generally the current model will have much more events of all the different types that we are looking for, and different acuities, very high and high. Remember that very high is the one that we are actually interested in, but we are also highlighting people that have high acuity events. If we compare that to the scorecard will also have from different type of events, or all the type of events and different acuities, but in less amount. If we look also, that's from the events from the past. If we look from the events that happen within the window of this prediction of within the next 6 months, we're actually going to see that the current model also have like more events from all the different types and both acuities, very high and high. And for the events after the label window, we also have much more events of all the types and both types, very high acuity and high acuity. By the way, all types of events for us that are relevant means ambulance runs, calls to the mental health crisis line, actually mental health services within the mental health center, and all the different services that they offer to actually help or mitigate these behavioral health crises. So we are actually identifying different events within the current model. The scorecard also does that, but in less amount. So it's interesting to notice like the differences between the actual solution and the scorecard. Also, it is interesting to notice that we have errors again in which the top K, for these 100 individuals, we actually said that it will have a behavioral health event in the next 6 months, but it actually didn't have in the next 6 months. But if we look forward in these events after label window, we actually notice that some of those actually have events of very high acuity after the 6 months in a window of 12 months. Also was interesting to notice that even some deaths on suicide and overdose happened after those 6 months. So the model is actually picking individuals before, even 12 months before those events happen. If we look at the crosstabs for the current model, or the current solution, we notice that the people that are at the top have much more frequent use of services, calls for ambulance runs, diagnosis, attempts of suicide, and all of those. Those happen like more frequently than the rest of the list. And for the scorecard, they happen to have like, because it is a rules set, the people that are on the top highlighted by the scorecard have these more of higher risk, right? That's the difference that we can see. If we look at the overlaps of the people that we can identify with these two solutions or these two models, we're going to see that if we are only looking at the true positives on these two top 100, we're going to see zero overlap, which means that we're actually highlighting different individuals. Scorecard is actually finding different individuals than us. And if we are looking at only the top 100, without the restriction of having true positives or not, we're going to see an intersection of 11 on average, 11 people in there. So it's very interesting to actually notice that we are identifying different people with different characteristics and different demographics in there. If we look at the performance on the current model is much, much better than the scorecard. But again, we are highlighting different people. And bias and fairness, in particular, our current model, or the current model for the machine learning, it's fair on race, but unfair on sex, but as unfair as the scorecard, which is not far away from our threshold of fairness. So I know that I have said a lot. That's the summary. So I would like to just show you some of these analysis that we look at before moving forward to the conclusions of the post-modeling part. If we look at the performance, you can see on the left, it's precision, the right is recall or efficiency and effectiveness. The yellow line corresponds to the scorecard. The blue one corresponds to the current model. You can see the difference in performance, at least in 100 individuals, which is the second point. So yeah, performance sits better on our current model. If you look at the second point of these 100 apps, it's these top 100 individuals. The left is the precision, which is efficiency, and the right is the recall, which is effectiveness. So we are better on that, but we already have known that because we actually selected this particular model. crosstabs looks like this when you are doing that analysis. So, for example, it's telling us for the current model, it's telling us that the people that are at the top have these 1,000 times more likely to have ambulance runs related to homelessness in the last month, or have 760-fold increase in number of crisis calls to the mental health center in the last 6 months, in the last month, and 739-fold increase in number of ambulance runs related to suicide. Again, all of these are the features that we were using on this particular model, so that's why they are highlighting in here. But those are like the main differences that we have for the top K individuals versus the rest of the list. That's how we actually know that the people that we are actually flagging on that model are the people that have more frequent events or use of the services associated with the behavioral health services. If we look at the scorecard, because they were using different features, this set of rules, we can see that these, for example, these 311 times more likely to have high risk of substance use, to be flagged as high risk of harm to others, of high risk of suicide, of hospitalization. So there are the rules that they are using over there. And mainly what we are trying to see is that the people that are highlighted by that particular model are people that are with high risk, flagged as high risk within their set of rules. That's how the crosstab looks like. If we look at the overlaps, just look at the first row, because that's like the top 100 individuals. You can see that we have these different intersection between those two sets on the list on the current model and the list on the scorecard, which is the average of 11, which I already have told you that. But if we only look at the true positives on that top 100, then we have a 0 intersection, which means that we are actually flagging different people, which is very interesting. If we look at the age, then it looks like this: different type of events and different acuity of events, bias and fairness. The orange one is the one that we are using, the current model. The green one is the one associated with the scorecard. In these particular plots, you would like to be at your right because you're having more performance and within these dashed lines. So if you're within those dashed lines, it means that you have a fair assignation of resources, because we're doing recall disparity in here. We are talking about gender in here and race on the right one. So for both cases, the current solution has a better performance with less recall disparity. And in case of race, we actually are fair, but the scorecard is not. So just to sum up, because I don't have enough time to go through all of this, but we do post-modeling to actually select one model, just one model from your subset, from the ones that you have, like with best performance and best bias, fairness measurements. Then you need to select one, which you do with this post-modeling analysis. The goal for actually using post-modeling analysis is to try to characterize which entities are you actually highlighting and which entities are you leaving behind. And it will give you information about all of those so that you can actually take like the best decision or the most informed decision to actually select the one model that you're going to put into the validation stage with a field trial. So I think that it's very important to actually notice that responsible AI, ML, or DS, or whatever word you would like to use in there, is not only about being transparent and having explainability in the models and also measuring the bias and mitigate the bias, which is a very important part of also being responsible AI. But it's also very important for us as analysts to actually take care of the analysis of who is actually part of this top 100 list or top K list, because those are the people that are going to be actually helped within your action, within your intervention. So it's very important to actually recognize that all the decisions that we made as analysts actually have a consequence in real lives So be very thorough about your analysis when you're actually selecting the model that you're going to be using um, for trying to achieve those goals that you defined when you were creating your project. So that's it on my side.